Hello, welcome to Code Design. Today we'll be solving LeetCode 721 accounts March. So let's look at the problem description. Given a list of accounts where each element account I is a list of strings where the first element accounts I0 is a name and the rest of the elements are emails representing the emails of the account. So first element, there will be given a list of accounts. You see each line is an account. The first element in each account is a name and the rest of them are emails. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there are some common email to both accounts. So this account and this account, they will be same account if they have at least one common element. So here we can see John Smith at gmail at mail.com. This is common between these two. And also, if two accounts definitely belong to the same person, if there is some common email to both accounts, note that even if two accounts have the same name, they may belong to different people as people could have the same name. So we could have people with the same name. Like here, there is another John that has an email address that doesn't match with any of this email address. So this John is different. So we have to keep these accounts separate, not merge with these ones, though they are all John. Even if the two accounts have the same name, they may belong to different people, as people could have the same name. Okay, a person can have any number of account initially, but all of their accounts definitely have the same name. So if we have common emails between accounts, their name has to be same. So this is what the input will maintain. If there is a common email between any two account, their name will be same account, same name. After merging the accounts, return the accounts in the following format. The first element of each account is the name. First element will be the name, and the rest of the elements are emails in sorted order. So these emails will be in sorted order, and the accounts themselves can be returned in any order. So we can return any order of this account. Like for this one, whatever would be our output, instead of John, the first row could be Mary, and then this John, and then this John. So order of these accounts output doesn't matter. So in this first example, what we can see that John Smith is common in these two accounts and name is John. So output will merge them. So we'll merge them into one account. So our output will be John and John 00 from here, John New York from here, and John Smith from here. So one of John Smith. There is two John Smith, but we don't need two, right? Because we are merging it here. For Mary, Mary does not have any other account, so we output Mary. And here, if you see that is sorted, this line is sorted in the output by lexicographical order. And John, the last one, we also output it. This is a single email. So here it says that the order doesn't matter that we discussed. Like if Mary comes first and then this John and then this John, that would be also accepted. So it doesn't matter. And there is another example here. Gabe, Kevin, Ethan, Hanjo and Fern, if you see that Gabe 0, Gabe 3, so all of them are actually different. And this is all Kevin, this is all Ethan, and this is all Hanjo, and this is all Fern. So none of them match. There is no common email in any of the two accounts here. So we can output in any order, but what we have to do in the output, we have to sort them. If you see that Ethan 0, 4, 5, then Gabe 0, 1, 3, that means they all are sorted. This is another example. So, what constraints we have? Our account length would be 1 to 1000. So, minimum one account would be there, and there could be up to 1000 account. And length of accounts I dot length. That means total how many elements would be in each line. That would be max 10, minimum 2 and 10. So, at least there would be a name and an email, and at best 10. And what would be the length of these emails? Length of this email would be 1 to 30, and they would be valid email. Um, and account names, name would be consisting of English letters. So all the emails would be valid email. So these are the constants. So, if you look at this program, this is a graph program, and we need to find components. So, what are the choice, right? So, one choice could be DFS for small amount of input. So, for these 1000 accounts, DFS still would be faster or good enough. But if you have larger accounts, right, instead of a 1000 account, if you have 100,000 account or a million account, then you have to go for a disjoint set or union find. So why disjoint set or union find? Because it find out group of related components, right? So it will find components, and the find operation is very efficient, and union operation also very efficient. So disjoint set I discussed in my previous videos, and there is a link also. I'll be sharing link of this page. So disjoint set basically group together connected it, it will group together connected emails here. Example 3. So I have some couple of examples which is easy to understand. So these are not valid emails, but say these J1, J2 represents email. So here you can see that John J1, J2, John J1, J3, John J3, J4, John J5, and Mary M1. So this John is separate. It does not match with any of the Johns here. And this John has actually a relationship, J1, J2, then J1, J3, then J3, J4. So they have common emails. So what we need, we have to, when we output finally, right, when you merge these accounts, we have to keep the name. So looks like we have to maintain a map of emails and account. So what we can do, we can actually look through all the elements, like we can look through all the accounts, and for each of the email, we can assign the account name if the account name is not already assigned. So we can use a hash map, and we can look up on the hash map, go through each and every email, and see if it has a name. If it does not, if the email is not on the hash map, we can put the email with the name. So on the first step, what we'll do, we will do like this. The output will be like M1 Mary, J1 John, J2 John, J3 John, J4 John, J5 John. So for each of the accounts, we consider will use the first account as the representative, because in disjoint set we use the parent or a representative for the set. So for each of the accounts here, the first email is the representative. So then initialize emails to parent map after initial emails to parent map, right? After initialization of disjoint set, what we do in disjoint set for each of the email, right? We will make the same email as their representative. So, or parent. So, parent of J2 is J2, parent of J3 is J3, J5 is J5, parent of M1 is M1. So, that is the initialization step of disjoint set. Next step, email to parent map after union find. So, now we will do a union find operation for each of the lines. So we will look through all the accounts. Say for first account, right? Our first email is J1. So we will union J1 and J2. If then here we'll union J1, J3, we will union J3, J4. And if we had more elements here, right? J4, J5, then each of them we would union with the first element, which is our representative. So we have more example there to verify those. So after union find, we'll get output like this. So J2, parent of J2 is J1, parent of J3 is J1, J4 is J1, J5 is separate, M1 is separate, and parent of J1 is J1. So from this, what we can see, parent of J1, J2, J3, J4 is J1. So the next step, right? Next step, merge accounts without account name. So let's try to merge this account. So I will go through the code eventually, but a little bit later. So here, for each email, we have to find its parent. So whatever emails we have, right? For each of the email, we'll find its parent and add the email to parents list of emails. So for each email, for each email, if representative M1 is representative of a set, right? So all the emails that M1 is represented for will be added here. So like M1 is default representative of M1, right? But J1 here we can see J1 is representative of or parent of all these J2, J3, J1 itself, J1, J2, J3, J4. So we add them in the map. We find parent of J1, parent of J1 is J1, and then we create a array list and then add all these element over there. So now that we are done with grouping, we need to find the account name for each of them, right? Remember that we have the name to account map. So from name to account map, we can look up using this representative M1 and find the corresponding name. Here we found Mary and we added in this array list, we added it on 0th position. Similarly here for J1, we find parent account name John and we added in the 0th position. And we saw, and before we add it in 0th position, right, we sort the array. So this is already sorted, but um, um, actually at this step, before we add this John at index 0, we sort these emails. So J1, J2, J3, J4, and J5. So finally merge account list. So what you can see here, we have whatever we need for our output. So we just need this list, right? So in the what we can do in this step, we can add this list to a new output list and then return the output list, or from this hash map we can get the values from the hash map, hash map dot get values, and create a new array list from here and return the list. So that would be this list. So if you can see, these are the values of the hash map, right? The first value, the second value, and the third value, which are list. Now let's go through one more example, and here we'll be going through for each of these step, we'll going through the related code. Here on example 5, we have the account David D0 D1, David D3 D4, D4 D5, D2 D3, D1 D2. And let's see how our code will look like. So in this one, we do email to name map. So this is our input. So we create a, hash map, string that will map email to name. And then this is our list of string account for, and this is all the accounts, right? So for each of the account list, or for each of this line, what we do, we take the first element as account name, here David, and then for each of the email D0 and D1, we put in the hash map if it is absent. So that means we put D0 David, D1 David. We do the same thing for the other lines. So if you can see, um, D4 David, D5 David, D0 David. So here everyone, all the emails point to same account, and account name is David. So this is the output after this piece of code. Now we will initialize the sets in this disjoint set. This is the constructor of the disjoint set class, and we'll pass emails. So how we can pass emails? We already have email to name map, right? So from there, if we do a key set, email to name map dot key set, then it will return us all the emails, right? All the unique emails. So we send all the unique emails, and then we can create a hash map parent map of initial capacity with the emails, and a rank, was we use ranking in disjoint sets. So with a capacity of n, we can create rank. And what we can do, the initialization, right? For each of the email, we make the same email as their parent, like below. D4 parent is D4, D1 parent is D1, D3 parent is D3. So email to parent map after union find. So now let's see how we'll do the union. So how we'll do the union? We'll go here, and this is our representative, right? So for each of the emails here, we will make union with the first email. For these also, for these also, for these also. That's what we are doing here. We are getting the first email, which is index 1 in the list. And for index 2 to end, right? That means other than the first email, all emails, we are doing a union with the first email. So this is one approach. Another approach could be you do a union with account.get I and account.get I minus 1. That also works. So next, we'll be merging the accounts, merging accounts without account name. So how we merge it? So for merge, we create a hash map merge emails where the key would be the representative or parent, and list of string would be the list of emails that associated with the parent. So here again, we take all the emails, email to name map dot key set, and we find parent. For each of the email, we find parent, and then this find is actually important because if you see this example, if we they are scattered through different accounts, D4, D3, here D2, D3. So we have to find the parent of each email where there will be path compression. So like for we'll see how it works, and then we will be after we get the parent in the merge emails map for that parent, we'll create a array list if it's not exist, and then here from these merge emails, we'll get the parent and add this email to his parent list. So if you see this output, so for D4, when we call parent, actually for D4 parent is D3, and then here parent of D3 is D0. So that means parent of D4 is D0. Then let's go for D5. For D5, parent is D3 and parent of D3 is D0. That means D0 is also D5's parent, and D0's parents is D0, D1's parent is D0, D2, right? For D2, D2's parent is D3, but D3's parent is D0. That means eventually D3's parent, D2's parent is also D0, and D3, we know D3's parent is D0. So if you see that after this code execution, there will be only one merge account, which is D0 in this hash map, because it only creates add a parent in the hash map if it does not exist. But in our case, for all of them, there is only one parent, D0. So it created only one parent. So this is the output, and finally, we need to sort them, right? We need to sort them and add the account name. So what we do in this merge emails for each, we have parent and which is D0, and we have all the emails associated with it. So these are our emails. We can sort collections or sort. We can sort these emails, which is our requirement. We need to sort it, and then we can add in the zero position, we can add the emails to name map dot get parent. That means the account name, right? Account name by parent we get here and add it in the zero position. Actually, there will be a array copy. A new array will be created by internally by adding the account name at the index zero and the sorted emails after that. So if we would, we could also use it here, a tree set here, which is a sorted set that we would not require any kind of sorting. But tree set is not efficient for these small 10 accounts. Maybe if there were more accounts, maybe that make more sense adding a tree set and not sorting. But for small number of emails, I think this will be faster. And then here, this is our merge accounts, right? Merge accounts is our output. So is a list of emails. So we simply can add this email in the output merge accounts. That's it. If we don't want to use this one, we could simply this is our merge emails, right? We could simply say merge dot values and then create a new array list with that new array list merge dot values. So after this one, we can see this is our output, and this is the map after we sort it, and here we do it right. We return this list as the output, and there is only one merge account here. What are the edge cases we could have? So there could be circular relations, right? A to B and B to C and C A. So if we are using disjoint set, this would be very this will be taken care of. And account with single email, we can check account with single emails as well. So let's look at the full code. Let's go here. So here, as I discussed throughout all these examples, I have broken down this account merge function into 4 steps. I created a merge account, which is list of string. That would be our final output to return. And this is our name to email map, where the key would be name and value would be account name. and map emails to account name. So this is the first step where we map emails to account names, and then we create the object of disjoint set. We have a disjoint set. We'll go and see the code. We send the key set of this hash map, which are unique emails, all the emails in all the accounts. And then here we, for all the accounts, we take the first email and then as representative. And for all the other emails, we do a union with the first email. The second step, right? Then we create a hash map of email and list of emails. Email would be our parent or representative. So for all the emails we find their parent. And after we find their parent, we create an empty array list if it is not present. And then again, from this hash map, we by parent, we get this list and add this email. So this is our third step, and fourth step is our that one, right? For all merge emails, we get parent and list of emails. We sort the email, add the account name in the first index, and then we add that email to the output. So I think this is good, and let's go and see the Disjoint Set implementation. I have previous videos also. I will give link where I discussed Disjoint Set and couple of problems I solved with these Disjoint Sets. So here, what you can see, set of emails. We create a parent hash map to map parent and to map parent and email, right? For each email, email will be key and parent would be the value. And we create a hash map with rank with initial capacity of n. Then we initialize it here. We have seen how we initialize for each of the email. We make the same email as parent. For the rank, we initialize rank as 0 initially. This is our find. So what find does? Parent dot get x dot equals x. If not, right? So whatever is our email, we get parent of this, and if they are not same, um, if parent and x email is not same, that means if they are same, we don't have to do any action, right? If they are not same, we call the find with the parent of our input email, and it will recurse and go and find the ultimate parent or representative. And once we get this representative by this recursive call, then we put it in this parent map. So this is my email, and this is whatever is the representative of parent. So path compression is uh, taken care of here. So for fast call, it will call recursively, but for next calls, when we have this, it will simply return this value. So since path compression is there, what value it will return? Whatever in this hash map. So it will directly, given AX, it will directly return the representative. And an union, right? To union X and Y, we do find of X, find of Y. So we get the representative of X and Y. Then if they are different, they are not same. If they are same, we don't need to union them, but unite them. But if they are different, we check the rank, right? Rank of P1 if greater than rank of P2, then we make parent of P2 to P1. If not, if rank of P1 is less than P2, then we make parent of P1 to P2. If they are equal rank, we simply put parent of P2 is P1, and we increase the rank of P1. So this is how union is working. So that's it. Let's run it. It should run. And actually, it passed the test cases as so it took 43 milliseconds. It beats 27.8%. Actually, I have also a DFS version and which perform much faster. As I said, the input is only 1,000 accounts. So DFS, it is okay for DFS to perform faster for this only 1,000 accounts. But if we have hundred of thousands of account or million account, then this then you can see how disjoint set is doing much faster operation. And now let's go and see time and space complexity. So this is the tricky. For if we have a number of accounts is n, right, and k is the maximum number of emails in each account I. For each account, if number of max element is k, then we have to actually do nk, right? Cause for um, any operation like when we create the name to email map or when we do the disjoint set, right? We have to do n into k times. And then we sort the accounts, right? Say at worst case, like we have David, right? All the five accounts went into one account, David. So in that case, you can see our sort will take nk log nk because nk is all the emails. N multiplied by k represent all the emails in all the accounts if they belong to one account. So that would be nk log nk. And again, for each of the emails, find operation would be alpha of n, where alpha is inverse Ackermann function, which grows very slowly, almost constant time, almost O1 after first call. So overall time complexity is O of nk log nk. And space complexity, we have n accounts, right? So we created merge accounts, merge emails, right? So that would be n, and we created here the hash maps for storing for the join set and for storing, right? Other things. So that is nk space. So we can say it is nk. I have also solved it using DFS, but that is also not very straightforward. So I kept it for the next video. Let me know if you like it or not.